For this exercise, we'll have an exponential decay model and we'll use a half-life to help us solve it. We have the model A is equal to A sub 0 e to the kt. We know the half-life of iodine 131 is 7.2 days. How long will it take for a sample of this substance to decay to 30% of its original amount? We want to round our answer to 1 decimal place. So let's start off, first of all, by noticing that K is going to be less than 0. The reason that we know K will be less than 0 is because we're told it's a decay model. So the first thing that we need to do is we need to look at our original equation right here, A equals A sub 0 e to the kt, and we need to use the information we have so that we can find out exactly what K is. All we know is that it'll be a negative number, but we need to know exactly what it is. So we'll use the half-life of iodine 131. We know the half-life is 7.2 days. So let's start off with our formula. A equals A sub 0 e to the kt. Now remember, A sub 0 is always equal to the original amount we start with. So let's write our A sub 0 down. If we have information about a half-life, and we do in this case, we know the half-life of iodine 131 is 7.2 days. That simply means that the original amount will decay to half of the original amount after 7.2 days. So therefore, the original amount A sub 0 will decay to A sub 0 over 2, just half that amount, in 7.2 days. So we'll have e to the k times, we'll substitute 7.2 in for our time. Now we have an equation that we can solve for k. In order to solve for this, let's first divide both sides of the equation by A sub 0. When we do that, the left-hand side just becomes 1/2, and the right-hand side becomes e to the 7.2 k. That's what will happen anytime we have a half-life model. When we divide both sides by the A sub 0, they'll just go away, and we'll end up with 1/2 on the left-hand side. Now we can use logarithms to solve this. Let's take the natural log of both sides. The natural log of 1/2 is equal to the natural log of e to the 7.2 k. So we have the natural log of 1/2 is equal to, by the rules for logarithms, we can take this exponent and bring it in front of our natural log. We have 7.2 k times the natural log of e, which I don't need to write because the natural log of e is just 1. So in order to solve for k, we'll divide both sides of this equation by 7.2. And when we do that, we'll see that k, by using the calculator, is approximately negative 0.096270. That's just the first 6 digits after the decimal. And we already knew k was going to be a negative number. So let's now take our constant k and substitute it back into our original equation to help us answer the question. So now we really have a model that says A equals A sub 0, our initial amount, times e to the negative 0.096270 t. The question we have is, how long will it take for a sample of this substance to decay to 30% of its original amount? So, again, we're going to start with the original amount, A sub 0. This time we want it to decay to only 30% of its original amount. So 0.30 A sub 0 is what I'll put on the left-hand side. That's how much we want it to decay to. So 0.30 A sub 0 equals A sub 0 e to the negative 0.096270 t. We'll divide both sides by A sub 0 and end up with 0.30 equals e to the negative 0.096270 t. we'll take the natural log of both sides. The natural log of 0.30 is equal to the natural log of e to the negative 0.096270t. By our rules for exponents on the right-hand side, we'll pull this exponent in front of our natural log, and we'll have natural log of 0.30 is equal to negative 0.096270t times the natural log of e, which is just 1, so I don't need to write that. When I divide both sides of this equation by negative 0.096270, I'll get that t is approximately equal to 12.5 days in this case. So to answer the question, it'll take about 12.5 days for our substance to decay to 30% of its original amount.